Right. Good morning, good people. We are starting the day now with our first lesson of grade 9 on Wednesday, and of course the 29th of July. We are going to continue to work out the different 3D objects, looking at a wide range of problems, but we are going to also relate our topic to the 2D shapes. In other words, we will have to check the difference between the 2D shapes as well as the 3D objects. And of course, it's very important that we participate. Participation is compulsory. So the first things first, I'm just gonna zoom directly into the first slide. And of course, it talks about the 3D objects which we have defined up to so far, and today we will be taking it further. Now, if you look at this particular polyhedron here, or in fact, this polygon, this 3D figure, which is bounded by polygons, is also called a polyhedron. And of course, we spoke about the different aspects and the properties of polygons yesterday. The one that is a 3D, as you know, it's a polyhedron. And so this is a 3D object. We talked about the vertices. That is what we did yesterday. We were able to reflect broadly on the vertices. And we also looked at the edges as well as the faces of the different 3D objects. And today we are simply reinforcing on those topics. And we should remember by now that the points of intersection of the edges of the polyhedron are known as the vertices. So all of those corners that you see in your 3D objects are known as the vertices. And of course, we also have the faces. You can see the faces and the line segments known as the edges as well. And that is what we have done up to so far. Remember, I also mentioned the hexagonal prism. And in this case, we said that the hexagonal prism has got 8 faces as well as 12 vertices and 18 edges. What is the difference between the pyramid and the prism when it comes to the hexagon? They're also known as the hexagonal pyramid as well as the hexagonal prism. I want you to focus on the two. The two are different. You can see that we have the prism, which consists of the base and the top, both of which are hexagons. So basically, you have 2 hexagons which are joined together with every corresponding point of the 6 points of a hexagon. And once you join them together, you can see a glass-like middle figure there, which demonstrates that there are about 6 faces in the middle. And then if you add the last 2, the top face and the bottom one, this should be able to give you 8 faces. And we spoke about that yesterday. And today we are just reflecting, just to show that there's a difference between the two. And of course, the prism as well, which consists of the pentagon, it's almost the same as the one at the top. So the bottom prism there, the pentagonal prism, the same as the top one, which is the hexagonal prism, in a sense that the base will always be your pentagon, and the top is also your pentagon. So definitely you have to find ways and means of differentiating. Remember yesterday, I also spoke about the homework where we needed to find the different faces and edges of a pentagonal prism together with a hexagonal prism as well. But at the same time, you also had to look at the pyramids of the two. So you'll have to now answer that as we proceed. Now I've got an object here, which is a 3D object consisting of the length, the breadth, as well as the height. You can see that the length of this 3D object is 6 centimeters, and the breadth is 3.5 centimeters, and the height is 5 centimeters. Basically, this is how different a 3D object can be from the 2D object, which consists roughly of only a flat surfaces. So this one has a height, so it therefore qualifies to be called a 3D object. Can I ask you once again, what type of a 3D object is this? What type of a 3D object is this? Is this a triangular pyramid? Is this a triangular prism? Maybe you should choose between the two. Is this a triangular pyramid or a triangular prism? Is this a triangular prism or a triangular pyramid? So the mistake is often made where learners are unable to distinguish between a pyramid as well as a prism. So those are some of the mistakes that can happen. So I just thought that this morning I must be able to demonstrate just to help you find a way to correctly characterize our 3D shapes. And of course, you can tell without doubt that there are two triangles here. So I can see that many of you, Jay, Pam, Kuba, as well as Kwezi, Mwabe and Tandon Gubani, they say it's a triangular prism. Yes, indeed, it's a triangular prism for the simple reason there are two triangles that are connected by the rectangles there. So you can see that we have got two triangles connected by the rectangles. This is a prism, unlike a pyramid, because in a pyramid, you wouldn't have two triangles. You'd actually have only one, which is the base, right? And then, of course, we have spoken about the cube, the cylinder, as well as the rectangular prism, as well as the triangular prism. So you can see right there, the yellow and red prism is called a triangular prism. And this is what we need in order to understand the different aspects of our 3D shapes. So basically, you need to analyze your prism in such a way that you can be able to see it even when it is unfolded. And I'm going to give you some work at the later stage just to demonstrate those. And of course, perhaps let me zoom directly into the one of the 2D shapes where we just want to calculate the area as well as the perimeter of the square. I just want us to zoom directly into the area as well as the perimeter of this particular square. The reason being, you need to broadly understand the square in order to utilize it correctly when it comes to the surface area. And I'm deliberately giving you these questions because when it comes to the calculation of the surface area in any 3D object such as the cube, remember that the cube is made up of squares. And you know that is where you will find a link between the activity that we're doing now as well as the surface area at a later stage, which will encompass the 3D object. Remember that this one emanates from the 2D. So I've already given you the difference between the 2D objects, the 2D shapes rather, as well as the 3Ds. I see JPEM Cuba says the area is equal to side multiplied by side, and that is 15 times 15. And of course, you get 225 square centimeters there. And I fully agree with you, because as you have just said, the area is given by side multiplied by side. That is the area of a square, which is given by the formula side times side. And if you multiply side by side, you get side squared. And therefore 15 times 15 is 225 square centimeters. Thank you very much indeed, JPEM Cuba. That was the correct answer that you gave. I hope that others are probably still working it out. I see most of you are replying privately. Okay, great. No problem about that. Right. I have noted your answer again, JPEM Cuba there. You've calculated the perimeter as well, which is done privately. Can I ask other learners as well to demonstrate and just to calculate the perimeter in this case and tell me what is the perimeter of this square with the length of 10 centimeters? And JPEM, that the answer that you gave me is the correct one. But before we can talk about it, I just want everybody to also have a chance to calculate the perimeter of the square with the length of 10 centimeters. So I do hope that we all have a pen and a paper, and we are probably calculating by now. Now, the area of the square has been done, has been calculated, and if I have to now demonstrate this to everyone, remember that our group chat is quite active. You can also have a look at some of the answers there as we continue to calculate. So remember that we said that the area which is represented by the big letter A is equal to side multiplied by side. And of course, our side in number one there is 15 centimeters, followed by another side which is 15 centimeters. Remember, in a square, all the sides are equal. Therefore, you have got 15 centimeters multiplied by 15 centimeters. And definitely, you know that as JPEM Cuba said, we should be able to realize by now that if you multiply 15 by 15, you'll definitely get 225 square centimeters. Just don't forget the units in this case will be square centimeters. That is where we are. So A will be equal to 225 square centimeters, definitely. So we are now going to proceed just to demonstrate how we get the perimeter there. So the perimeter as well, remember that in a square, you simply multiply the side by 4, because a square consists of 4 sides, and so our perimeter will just be 4 multiplied by the side. And of course, 4 times, the side in this case is 10 centimeters, and then 10 times 4 will be 40 centimeters. So in this case, all that you need to do is to demonstrate the use of your understanding in as far as the perimeter is concerned. And we say that P is equal to 4S. And then you multiply 4 by 10. And then if you multiply 4 by 10, you'll get 40. I'm sure you'll agree with me that 40 will be the correct answer there. So in this case, we say 4P is equal to 4 and then open bracket and then 10 centimeters. Thereafter, you close your bracket. Indeed, as Cuba said, I see Tandong Guban as well. You have managed to calculate correctly. The same goes for Tandim Tembu, who also found the perimeter to be 40 centimeters. So thank you very much indeed for those who just took the time and taking part in this activity. One of the key things that we need to do is the ability to substitute correctly. And this is followed by the area of a triangle, which is based on the two given sides. One of the sides is the height of the triangle, followed by the base. And once again, I'm deliberately giving you this activity because I want you to remember when we come to the surface area, for instance, of a triangular prism, you should know that there are two triangles there. And once you can be able to find the area of one of the triangles, then you multiply that by 2. And then you can do the areas of the 3 rectangles. And that will give you the total surface area of your triangular prism. And the same goes for a triangular pyramid. You do it differently. You look at the sides, and then you look at the triangle, which will be your base. So it's very important because if you cannot simplify a simple 2D object, it might be difficult when it comes to the 3Ds. So now, I see that, Pam, you have already shown your triangle there, and of course, I'm happy with your answer, and that is the correct answer. Tandim Tembu has said that you multiply 6 by 10, and then you divide by 2. I see followed by Tandong Gubane. So basically, JPEM has found that the area is 30 square centimeters in this case. And your answer is now corroborated by Tandim Tembu, who also agrees with you, and of course, seconded by Tando Ngubane. And I see that you have put in place the correct formula, half a base multiplied by the perpendicular height. Now, that is what we do. So Renai also agrees, great. So basically that is what you do. You need to remember, all of us, that the area of any triangle has got a formula. And that formula is half of the base, and then you multiply everything by the height. And not just the height. Not just the height, but also known as the perpendicular height, all right? So that's the perpendicular height. So you multiply, you take half of the base multiplied by the perpendicular height. And of course, all of us should remember now that A will be equal to 1/2, and then the base there will be is given as 6, and then you can see that that is 6 centimeters, and then the height is given by 10. So you'll have 10 centimeters, and then you close the bracket. So basically, it's up to you how you proceed. You can multiply 6 by 10 as Tandy said to get 60, and then thereafter you divide everything by 10. So I've been now, right, the answer that I've written there is actually showing that what we need in this case is just to multiply the 2. So you can multiply the 2, and then of course, half of 6 is 3, and then 3 multiplied by 10 gives you 30. Remember, it will be 30 square centimeters, not just 30, but it will be 30 square centimeters. Now, can we proceed to the last one, which is now the perimeter? Right, the perimeter of this particular triangle. Now, the triangle is different in a sense that it's an equilateral triangle. Remember, the previous one, the base was 6 and the height was 10. Now, in this triangle, we have 3 equal sides. The 3 equal sides, which are 40 centimeters each, and then we need to find a way just to correctly calculate. I see JPEM once again was the first to respond in this particular activity. And I can see your answer there, JPEM Cuba. And you are seeing that you multiplied 3 by 40. Great. I'm glad that you did that simply because this is an equilateral triangle. But what about the rest? What did you find? Let's check what you found. What did you find the perimeter to be? In this case, there are 3 sides. So you simply add the sides. Basically, that is what you need. So you are just going to add the sides of your triangle. And I see that Renai says 120 centimeters. And that was done by Renai there. And I fully agree with you. Your answer is just the same as the one that was calculated by Cuba there. And of course, this means you simply add you add 40 again, and there will be 3 of those, which means that your P will be 120 centimeters. So I fully agree with you. Thank you very much for taking the part in this activity. Once again, let's carry on. We are not going to waste time. I hope that those who were busy with this activity will now see how we have calculated both the area and the perimeter of the triangle. Remember, this lesson plays a role, especially when it comes to our 3D object. You need to know and understand how to calculate the area and the perimeter of 2D shapes. So Tando Ngubane as well, saying that the perimeter is 40 plus 40 plus 40, which is 120. So thank you there, Tando Ngubane. And let me not waste any time. We have now come to another activity which we need to look at. Yesterday, I spoke about the faces of the 3D shapes, or rather the 3D objects as we call them. Now today, I'm looking at the first one, which is a cube, and I want us to find out how many faces are there in a cube. Just to recap our 3D objects, how many faces? And then you need to, after answering this question, then we are coming to the type of the shape. Okay, fine. Pam, I see you've already answered the first 2. Good. Okay, thank you very much indeed, JPM Cuba. And let's carry on with the rest. I see JPM was the first to answer, and that is correct, by the way, JPM, I agree with you. But before we can talk about your answer, let's give everybody a chance as well. Just 30 seconds. Let's answer this. Okay, Renai, I can see your answer. Can see your answer there. And that too is correct. Renai, that's the correct answer. Can we proceed now? Okhantse, I see you also came in there just to demonstrate that you've got about 6 faces. So up to so far, there are 3 learners, JPEM, Cuba, Renai, as well as Okhantse. Can we give other learners a chance to also reflect? Right, I see that Tandim Tembu as well as, who else? Okay, Tando Gubani says 6 faces, great. There are definitely 6 faces in a cube. There are 6 of those. But what type of shape or what shape are they? What is the type of the shape? Is it a rectangle? Is it a triangle? What type of shape is this? Or those faces? Right, Tandong Gubani says they are squares. Right, Renai also saying that they are squares. Tandi Tembu also saying they are square. Right, yes, in any cube, you will definitely have squares. That is what you will have in any cube. So always when you have a cube, remember that you will always have the squares. So, right. And let me also, before we carry on with the last few questions here, just to remind you once again of the importance. Those of you who wrote the test, just to email those tests which are marked. You can just email them to the HOD, and I'm just gonna give you the email address shortly. I will put it in the group chat, the email address for the HOD. You can just email some of those just to ensure that you are able to carry on. All right. Let's just ensure that we are able to carry on with our work. And the first one I see 4.1, JPEM Cuba has already answered that. Just remind you, before the end of the lesson, I will give you that email address where you just need to email your statements or your results about the test that we wrote not so long ago, about a week ago. In fact, 2 weeks ago, yes. Right, now we have to name the 3D shapes from this net. Remember, in order to construct any 3D object, you can start by constructing a net. And thereafter, you can use those nets to conclude or just construct your 3D shapes or objects rather. I normally call them objects because these are things that you can actually hold. It's not just a shape that you can draw. Right, the first one I see JPEM Cuba saying that the first one is a rectangular prism, followed by, I see you say a cylinder. Great. And I see you have also answered the next ones, but let me focus on the first one. Right, Okhantse also saying the rectangular prism as well as a cylinder. And then Renai as well saying the rectangular prism, 4.2, the cylinder. And indeed, that is so, that is correct because the rectangular prism together with the cylinder those are the nets. If you look at the first net, it consists of several rectangles, and that is basically what you need to complete a a 3D object, which is known as a rectangular prism. And the cylinder as well, we can see you cut 2 equal circles, and then there's also a rectangle. Now, if you fold your rectangle, you should be able to now be able to complete the task of constructing your cylinder there. So the fourth one is a cylinder. I agree with all of you. So James, I can see your answer together with Renai, Okhanse, and Tando Ngubani and Cuba as well. Great. Tando Ngubani saying there are 5 faces, all right? How many faces does a triangular prism have? So you have answered that now. How many faces does the triangular prism have? And I'm going to have an additional question there. So Renai has answered that, great, together with Tando Ngubani. I'm glad that we are up to this stage. We have been able to answer those. But the key question now is what type of shapes? What are the types of shapes? So we can start with a triangular prism there. What types of shapes are there? So Tando Ngubane, I've seen your answer. Tando Renai, I've seen your answer. And then I've also seen JPEM. Thank you very much indeed. JPEM has went on to classify the number of shapes that are there. I'm glad that you can see that. Renai is saying the shapes are triangles. Renai, is it only triangles in the triangular prism? Does it consist of only the triangles? And then Onka says the rectangle and the square. That is what Onka is saying. The triangular prism, Onka says, is the rectangle and the square. And perhaps just to take you back, there's we had something like this. This is a triangular prism. So I want you to look at the triangular prism and just analyze. I see Unka saying the triangle. I agree with you, Unka, when you say triangle. When you also say rectangle, great. I fully agree with you. I was just worried about the square when you mentioned the square, and perhaps it's possible to have a square if you have the base. You may actually have a square, but in this case, there are rectangles, as you can see. We have about 3 of those. If it is squares, then it will be 3 squares. But usually it will be a triangle. It will be the rectangles, as I've said. You can see even in the picture that we have got 3 rectangles and 2 triangles. And this was correctly answered by Cuba, JPEM there, who managed to tell us that there are 2 triangles and 3 rectangles. So basically, that is what we have. Right, we are now going to proceed to do what we have to do just to carry on with our lesson. And of course, these were the questions that we had to answer. So the questions that had to be answered was the first one, which is the 3D shape, together with the type of shape, and then of course the nets. Without wasting time, just to give you this worksheet, which you can work on as and when you find time, you can just name the shape which you see on the board. What type of a shape is this? And then you mention the number of faces there, the number of edges, as well as the vertices. You can see the top right one, that is the cone, I believe. And then you can just mention what do you have there, the different shapes that are there. And then of course the vertices together with the edges. Just to recap once again, if I may ask, we spoke about the triangular prism. And yesterday, we managed to look at the triangular prism together with the number of vertices as well as the faces. Just to recap, how many faces are there in the triangular prism? I see, Unka, you have spoken about the rectangular prism. You say there are 8 vertices, 6 faces, and 12 edges. Right. But I'm now taking you back to the triangular prism, which you have just done now. How many faces are there? Right. I see that JPM says there are 5 faces, and I fully agree with you. The first 2 faces are those of the 2 triangles, and the 3 faces are those of the 3 rectangles. Thank you very much. So in total, you have 5. Great. And the vertices, how many vertices are there? Right, Onka saying there are 6. Great. I fully agree with you, Onka. You are saying there are 6 vertices and supported by JPEM. So that will be 6. And then we have just wrapped up on the type of dimensions together with the vertices and the edges, just to show those who may want to check what do we mean when we talk about the face of a 3D object or a polyhedron, as we know. Right, we spoke broadly about the cubes and the cuboids, and this we have defined together with the cone, and this we have done yesterday. We have also looked at the different shapes. If you can just check, where you had to find the correct shape from the 3 possibilities. So the first one there, we have given you the 3 possibilities, and you need to link this to the correct shape. So if you look at the first shape, that is all right, the first space there, that is a sphere, followed by a pentagonal prism and a hexagonal prism. Now we are told that one of these has got 8 faces and then 18 edges and 12 vertices. Which one is that? Let's link the correct shape to the 3 possibilities there. Can we link it to the correct shape? Now, in order for you to link it correctly, you will recall that if you look at the hexagonal prism there, it has got about 5 faces in the middle and 2 at the top and bottom. So it actually has 7 faces. So meaning that it is out. It can't be the one. And the cone, someone says the cone has 2 faces and has 1 edge. That is tandem temple. Now the cone, all right, we are not yet at the cone. We are now in the first row. The first row, we just have to link the correct number of faces. It says 8 faces. So obviously, if you look at the last prism there, the hexagonal prism, it will have 8 faces. There will be 6 in the middle, and then the top face and the bottom face. So there are 8 faces. Therefore, that notion of 8 faces can be linked to the hexagonal prism, meaning that in the first question, the hexagonal prism is the answer. All right. I see Tandon Guban also agreeing, saying the hexagonal prism. Great. Great. Now we have the second one has got 5 faces, and then 8 edges, and then 5 vertices. Which one is it gonna be? Is it the square-based pyramid, or is it the triangular prism there. Remember, we just spoke about the triangular prism just now, and we just defined it. So Tando Ngubane says the square-based pyramid has got 5 faces. How many faces are there in a rectangular prism? There are also 5 faces, right? So it means you need to now check the vertices. Remember the vertices, I said they emanate from the corner. So I fully agree with you, Tando. It will be the square-based pyramid. The reason being, if you look at the vertices of the triangular prism rather, there are about 6 of them. So you only have 6 of those. So that cannot be. So, but if you look at the vertices of the square-based pyramid, there are 5. There are 4 angles at the bottom and then the edge at the roof there, or at the top of the pyramid. So you also have the edge there, the vertice there at the top. So basically the vertices reflects only the angles, as I said, or they are more similar to the angles, right? And then the next one, you have 6 faces and then 12 edges and then 8 vertices. And Tando says it is the rectangular prism. The rectangular prism. I agree with you, Tando. Even Tandim Tembu says the rectangular prism. Great. I'm glad that now we are moving. So we can correctly go to the next one where there are 7 faces and then 15 edges, 10 vertices. 7 faces, 7. It should be very clear at this point. 7 faces. Pentagonal prism, yes, Tando Ngubane as well as JPEM. Cuba says the pentagonal prism. Great. I'm glad that we are now able to answer. Then the last one, let's go to the last one, 7 faces, 12 edges, and then 7 vertices. You can see this is different from the other one. And then JPEM says the pyramid, the hexagonal pyramids. Okay, great. How many faces will there be? So there'll be 1 face at the bottom, 1 face plus 6 faces around the pyramid. So 6 plus 1 is 7. So there are 7 faces. All right. So there are definitely. But remember, even the pentagonal prism also has 7 faces. But the distinction here will be on the vertices. So the vertices will be 7 for a pyramid, the hexagonal pyramid. There are 7 vertices. That's what makes it different. That's what makes the two different. Right, and then I had actually said that you should find those pentagonal pyramids. We've just done them by extension in a sense that we looked at the examples that we just had, some of which consist of the hexagonal pyramid. I mean, I've just shown you now the hexagonal pyramid, which Tando Ngubane and JPEM spoke about. And then perhaps the only one that we may do is the Pentagonal Pyramid. Let's now talk about the Pentagonal Pyramid. How many vertices are there? How many faces are there? And how many edges? Right, I see that JPEM says there will definitely be 6 vertices and then 6 faces. and then 10 edges. Is that for the Pentagonal Pyramid? 5 plus 1, yes, I fully agree with you, yes. Yes, the vertices will be 6, and then also the faces will be 6, and there will be 10 edges. I fully agree with you. Those are the properties of a pentagonal prism. By the way, we did not have enough time to mark this work. Just once again, take it as your homework, just to find the different faces of the different polygons that are there, or polyhedrons rather. Once again, as always, this lesson was brought to you by the STEM Digital School in partnership with Sasol Foundation, the STEM Digital School being the brainchild of Africa Teen Geeks. And of course, this is under the leadership of Ms. Lindiwe Matladi. And let me thank you, all of you, until we meet again tomorrow. But before we close, allow me to give you that email address where you need to send your scripts. pilisiwekele@gmail.com. So I've just typed the email address. Let me just type it for everyone to see, pilisiwekele@gmail.com. So please email those tests to pilisiwekele@gmail.com. Thank you once again. Have a nice day.